Alrighty, and we're back, and what we're going to do is look at a little bit of a little more of an in-depth application of installment loans and annuities. So let's say you have a mortgage where you borrowed $180,000 and you borrowed it at 4% annual interest and you're making monthly payments for 30 years. So right away, we notice the missing information is the payment, and we can easily find that. Our goal is going to be to figure out how much do we still owe after making 10 years of payments? And you might have some ideas there. You might just say, well, if I know the payment, I'll just multiply by, 10 years worth and subtract. But remember, with interest being factored in here, it is going to be maybe quite a surprising result. So let's get into this. So we know already that using since 180,000 is a beginning amount, we know we're going to use the formula 180,000 equals P times this thing. 1 plus 1 interest rate over 12 raised to the negative 360 again because it's 360 payments, right? And then we're going to divide that all by 0.04 over 12, and then we'll work the calculator magic. We'll find our payment and round it to the nearest penny. So you have 1 minus 1 plus 0.04 over 12 raised to the negative 360 divided by 0.04 over 12. So there's the quantity in parentheses. And if I divide 180,000 by that, we get 859.35. It looks like rounded to the nearest penny. So 859.35. So cool. We have 360 payments of $859.35 that are being made. Let's say we've made 10 years of payments, which might translate to 120 payments. Well, not might, it does. So our big question is going to be now, what's the remaining balance? And the key idea is, I have this balance that I don't know. So it's like a new starting point almost. And what is ahead of this balance? 240 payments of $859.35. Okay? So we have 240 payments remaining, and remember, if we're concerned about a lump sum now with payments ahead, that's the setup, right? It's number of payments that have yet to come. So this is just basically using the annuity formula again, but with different information known. We don't know the balance, but this time we do know that we're making payments of $859.35. Same information in here, except this time we're using negative 240 because we're only concerned about the next 20 years. And again, calculator magic, we'll see what happens. 1 minus 1 plus 0.04 over 12 raised to the negative 240 divided by quantity 0.04 over 12 and then times 859.35. So 141,811. Oh, and there were pennies there. It was 53 cents. Now, although it wasn't asked for, let's just do a little bit more exploration here. So at this point, let's just look at how much of the loan is paid off. Well, we borrowed $180,000, and we still have a balance of this remaining. So how much of the actual loan got paid off? That looks to me like $38,188.47. Now the other question is, how much did we pay? On the loan? Well, we made 120 payments of $859.35. Ooh, this is going to be a big number. $103,122. So just take a look at that. We only paid $38,000 off toward the loan. This is how much money came out of our pockets. So if we look at the interest paid, it's the difference between these two. Which is a lot of money. $64,933.53 in interest. Copied it down wrong there. 64,953. So a lot of interest happening in the beginning part of that loan, but this was just something really interesting to look into. So the answer to the main question being right here. Thank you for watching, and when we get back, we're going to look at specific interest rates. How would you estimate the APR if you know how much you're paying back and you know how much you borrowed? So stay tuned. Thank you for watching.